Alrighty guys, we are on 7.1.4. This lesson is how can I solve it? Take 1 second. I'm going to post the intro and I want you guys to read through it and just understand what we're doing. Okay, the Sutton family took a trip to see the mountains in Rocky Mountain National Park. Linda and her brother Lee kept asking, "Are we there yet?" Parents, does that sound familiar? Yep. At one point, their mother answered, "No, but what I can tell you is that we've driven 100 miles and we are about 2/5 of the way there." Linda turned to Lee and asked, "How long is this trip anyways?" They each started thinking about whether they could determine the length of the trip from the information they're given. Okay, so if we look at Linda and Lee's methods, both of these right here, Linda's method, she's using the number line. Lee's method, he's using scale factor that we've looked at. Okay, so part A, what I want you to answer is, what does X represent in each diagram? Okay, so just give us a quick answer for that. For part B, what equation could represent the situation? Use the scale factor or the multiplier to represent the situation in an equation and let X represent the total distance in miles. So when we look at what X represents, there's your answer, right? X represents the total distance in miles. Right, so for B, so if we were to write this, 7-39, this is on the left-hand side of your notebook. If you're still following that, 7.1.4 is our section. Okay. Our scale factor, if we look at here, this is our scale factor, right? So this is new over the old, what we're looking at. So we have X being the total distance. Right? And so when we write our equation, we're looking at pretty much what the diagram shows us, right? So X times 2/5 equals 100. This is how far they've gone. Okay. Or if you were to write this more neatly, right? 2/5 X equals 100, right? So same thing. Okay. So question, right? So we always want to give a reasonable estimate and figure out where our thoughts should be going, right? So what would be a reasonable answer for this? So for part C, I want you to tell me, is the answer going to be more or less than 100 miles? Explain your thinking. So just tell me, is it going to be more or less than 100 miles? So when we look at the total distance, it should be more than 100 miles. If you look at Linda's method, that's what I like about Linda's method, is it shows that they've only gone this far. This is how far they've gone. Right? And then X would be the total distance. Right? So if you know that they've gone 100 miles, you can kind of guess with this part, guessing how much more it is, right? So first question was, is it going to be more or less than 100 miles? Second question is, what would be a reasonable answer for this? So I don't want you to calculate anything, just kind of guess. Okay. So Linda remarked to Lee, "When I look at my diagram, I see that the total distance is 2.5 times the distance we've driven. Do you agree?" Okay, so how can you add labels to Linda's diagram to show 2.5 times the distance, right? So we're going to draw this diagram, 7-40, underneath this, part A. Let's draw the diagram. How much do we got? 5 spaces. Okay, so 5 spaces representing the denominator, the fifths. This is 2/5. On the top of the number line, we have 100 miles. And this is X, the total. Okay, so the way we annotate this, the way we look to show 2.5 times the distance, there's 1. There's another 2/5. That's 2. Right? And then this is just half of that, right? Because there's only 1/5, right? So this would be the 2, this would be the 1/2, right? So That would be that. Okay. How long is the trip? How do you know? Let's annotate let's look at the top part. Right. So if 2/5 is 100, again, another 2/5 would be another 100. Half of that would be what? 50. So you know the total. So for B, the total distance is 250 miles. Make sure you label your answers, okay? And just showing you how you know this is what we're looking for. Okay. 7-41. Lee thinks what he knows about similar triangles can help. So go back and review 7-22, which involves similar triangles. How are scale factors related? All right, so we're talking about the new over the old, right? And then just scaling figures, making it bigger on all sides, make it smaller on all sides, and every dimension, every angle, right? Okay. How can the relationship of the scale factors between similar shapes help Lee? Find the missing scale factor in his diagram at the right. So if we look at this, right, what could he multiply by 100? So if you're going this way, right, we're multiplying by 2/5. If we're going the other way, usually I tell you guys what's the opposite operation, right? So in the opposite operation, instead of going this way, we multiply. If we're going to go backwards, we're going to divide by 2/5, right? The same thing when we do this is going to be multiplying by 5/2. And we'll look at this. We'll look at this later, okay? So actually what I want you guys to do, sorry I didn't tell you, is to draw this diagram into your notebook for 7-41. So draw the diagram. Use the new scale factor to find x. So remember, when you're going one way, multiply 2/5. When you move the other way, you can multiply by the reciprocal, which means that you're flipping denominator and numerator, and you just use that to find x. So this would be 100. After you draw the diagram, 100 times 2/5. Right, oh sorry, not 2/5. Times 5/2. If I multiply straight across 100 times 5, this will give me 500 divided by 2. This will give me 250. Right, so same answer. Does it agree with the one you found in part B of 744, so the previous problem? Yes. Moving forward. Okay. As Linda and Lee were talking about the problem, their mother overheard and offered them a different strategy. Here's how I would start by solving the problem. She showed the example at the right. So first, copy down this example on the right, right? Okay. Lee says, I see a giant 1. Where's the giant 1? Okay, I'll rewrite it too. Okay, so where do you see the giant 1, right? If we look at this right here, a number over a number, right? 100 over 100, that's 1. 10 over 10, that's 1. A billion over billion, that's 1. 2/5 over 2/5 also equals 1. Okay, so there is our giant 1 for us. And the left side then just becomes x. Okay. One way of making sense of 100 over 2/5, right? So we see a fraction within a fraction. That's called the complex fraction. Is as 100 divided by 2/5. These are the same things. This could be read as how many 2/5 are in 100 wholes, right? And I'm gonna break this down for you. If you were to choose a different number, so if it was like 100 over 50, we would say how many 50s are in 100, right? And then you would know that that's 2. It's the same thing. How many 2/5 are in 100? And so I want you guys to think about this. So how many 50s are in 100? There's 2, right? 2 50s. How many 1s are in 100? There's 100, right? How many 2/5 would be in 100? And I want you to think, go back to the original question, would it be more than 100 hundreds? Or sorry, would there be more than 100 of them? Or would there be less than 100 of them, right? And because our number gets smaller over here, right, there's going to be more room to fit in the 100, so it's going to be more than 100. I don't know if that makes sense, but we'll just keep going. Okay, and then as we practice a little bit more, we'll go on to it. Okay, so Lee began to wonder how this diagram could help him solve his mother's equation, right? So remember, this diagram is what we're looking at, right? Going one way, we multiply 2/5. Going the other way, we multiply by 5/2, right? The reciprocal. So if we do the same thing, does his work relate to the similar triangles diagram? So I really want you, this is where our work is headed. So 7-43. Okay, this is where our work is headed. So let's copy down this equation. 2/5 x equals 100. Remember, the mom, previously what she did was divide both sides by 2/5. What he's doing, I'm going to rewrite this again, is he is multiplying by the reciprocal. 2/5 x equals 100. And I'll write this in a different color. Right? Okay, so is it the same thing? Now let's look. On the left-hand side, right? Giant 1, yes? On the right-hand side, now we can simplify for those of you, but I'm going to break it down even more. If I multiply straight across here, 5 times 2 is 10. On the denominator, 2 times 5 is 10. What's 10 over 10? This also gives you a big 1. And I'm bringing everything else down, right? So that section right there, this part right here, also gives you a big 1, okay? Finished Lee's work to solve x, so let's solve for x. On the left-hand side, this leaves me with x. On the right-hand side, I've got 100 times 5, which is 500. Put it over 2. 500 divided by 2 will give us 250 miles. So now we have more tools in our toolbox to be able to solve this question. Okay, let's do some practice. I know this is confusing. Okay, so Linda and Lee wondered how these new equation solving strategies could work with different equations. They made up more equations to try to solve. Okay, so we're going to try and solve these by ourselves. But pause the video and then I'm going to go over it actually. Okay, so I'm going to do the solving equations method, okay? So I have 9/2 x equals 27. Our goal is to make that giant 1, right? So what we can do is divide both sides by 9/2. Right, 7-44, write this down. Right, the same thing as dividing by 9/2, I'm going to rewrite this, is to multiply both sides by the reciprocal. Right, meaning we're flipping the fraction. Okay, so on the left-hand side, remember, 2 times 9 is 18. 9 times 2 is 18, so that gives us a giant 1. X equals, multiplying it on the other side, I've got 54 over 9. This will give us an answer. 54 divided by 9 is 6. Okay. Part B, right? So here we go. I'm going to do this the equation way, right? And then I'll show you another method to do. So again, we can divide both sides by 2/7. Make that a bigger fraction bar. Rewrite it again. Dividing by 2/7 is the same thing as multiplying by the reciprocal. Reciprocal will be 7/2. Right? Okay, so here I got a big 1 on the right-hand side because if I simplify now, 2 divided by 2 is 1. 7 divided by 7 is 1. This gives me x. Left-hand side, 7 times 12. This will give me 84 divided by 2. X will equal 42 on this side. Okay. The other method that we can use, 2/7. Is that what? Okay. 1, 2, 3, 4, 5, 6, 7. 7 spaces. Okay, so 2/7 is going to equal 12, right? So on the other side, this is 12. So if 2/7 equals 12, that means every single time we have 2/7, this is going to equal 12. Okay, Now the last part, I only have 1/7. And so half of that would be 6, right? Add all of them together. 12 plus 12 plus 12 would be 36. Plus 6 is 42. Okay? And then it all just depends which method you want to use. Sometimes some are easier than the others. Okay? Last one. So I'm going to skip this part. But our last one, instead of dividing by -3/4, don't forget the negative, we're going to multiply both sides by -4/3. Right? On the left-hand side, right, 4/4 is 1, 3/3 is 1, and our negatives as well. This leaves me with x. On the right-hand side, I've got 21. We'll do this simplifying way, right? So what can I divide both 21 and 3 by? I could divide both of them by 3. So 3 divided by 3 is 1. 21 divided by 3 is 7. And now I can just multiply straight across. 7 times -4 will give me -28. Right? So you can see which ones take up less room. I was trained with the equation method, and so that one's a lot easier for me. But it's also less work that needs to be shown. If you like the number line method, go right ahead. If you like drawing triangles, that's also up to you, right? Whichever one you want. Okay, let's do some practice problems and then pause and rewind and rewatch, I would say 7-44, just if you need any review. Okay, thank you.